Okay, so this question is about assessing application of Gibbs free energy, and this is a self-created problem. And in this problem, uh, we determine spontaneity of the following chemical reaction using Gibbs free energy and given data. Given data mean entropy data is given. Is the given reaction spontaneous at room temperature, which is 25 degrees Celsius? Explain the answer. So basically, we have oxidation of methane, and oxidation of methane is making carbon dioxide and water. So we have heat of formation data at 25 degrees Celsius, which is given here for all the reactants and products. And then we have entropy data for all the reactants and products as well. So this is the data which is given. We will use Gibbs free energy rule for telling either the process is spontaneous or not, right? So basically, if you remember, we know that if delta G, which is equal to delta H, which is enthalpy change, minus T delta S is less than 0, then this process is a spontaneous process. So spontaneous process. If it's greater than 0, then it's non-spontaneous process. So this is the logic which we already know. Now first what we can do is we can calculate delta H, which is here, which is change in enthalpy of the reaction. So first we can calculate delta H, which is delta H is equal to heat of formation of products minus reactants. Heat of formations of products minus heat of formation of reactants. Okay, now this is basically the rule. Let me open that slide for you guys as well, if I can see that. So the slides are here. So this is the problem which is given here. So basically now what we will do, we will calculate delta H by, we have reactants and products. So basically CH4 and O2 are reactants, and CO2 and H2O, they are products. So what we will do is, first of all, we will calculate delta H for product side, which is CO2. That is, for example, for carbon dioxide, the coefficient for carbon dioxide is 1, So basically coefficient multiplied by heat of formation for CO2, which is this one, minus 393.5 kilojoule. Maybe I can remove the unit, plus for product water, which is 2, right? So 2 into water heat of formation is this, which is minus 241.8. This is for the product, minus same process for the reactant. First for CH4, CH4 is 1, so 1 into minus 74.8 plus oxygen, because this is in atomic form, so basically for atomic forms it's 0, so 2 into 0, so this is for the reactants. So basically delta H is, we can calculate using this, so you can follow this as well here, which is minus 802 kilojoule. So basically the answer is, so delta H is minus 802 kilojoule. So the negative delta H mean the heat is being released as a result of this reaction. That means this reaction is an exothermic reaction. So this reaction is exothermic reaction, because it's oxidation reaction, and normally oxidation reactions are exothermic reactions. So we have calculated change in enthalpy, which is delta H. Now the same thing we can do here for change in entropy, which is delta S. The same rule applies, that entropy data for the product. So basically entropy data for the product minus entropy data for reactants. So this is the same rule we can calculate following the same steps. So delta S is equal to, again for the products, first carbon dioxide, number of moles is 1, entropy is 213.6 for carbon dioxide, which is this one, plus 2 water, which is this one, 69.9, minus CH4, which is 1, that is 186, plus 2 for oxygen. Oxygen is 205. This is for the reactants. So as a result, we will calculate delta S as you can see from this, minus 242, or maybe 243, we can do that. 243, delta S is minus 243 kilojoule per, no, sorry, joule per Kelvin, which is joule per Kelvin. So joule per Kelvin, which becomes minus 0.242 kilojoule per Kelvin, right? So to be consistent. Now based on the entropy change is negative, that means entropy is decreasing. If entropy is decreasing, that means process is not spontaneous, right? So let's put these values in this Gibbs free energy equation, which is delta G is equal to delta H minus T delta S. So we have calculated delta H already, which is minus 802 kilojoule, minus temperature is 25 degrees Celsius, which is 298 Kelvin, multiplied by delta S, which is minus 0.242 kilojoule per Kelvin. So basically Kelvin cancelled, so we will get delta G is equal to, if you can use your calculator, delta G is minus 730 kilojoule. So delta G is minus 730 kilojoule. So which is less than 0. So that means based on delta G, process is spontaneous process. But based on the entropy, this is non-spontaneous. So basically that means the entropy data of these like components is not correct, because if it's spontaneous based on delta G, it should be spontaneous based on entropy change as well. So that means the data of entropy which is in this question is not correct. So because in both cases the results should be consistent, because this is not possible that based on Gibbs free energy change the process or reaction is spontaneous, and based on entropy it's non-spontaneous. So basically it looked like the data either of CH4, which is this one, or this one, which is 205 for O2, these are not correct, because in the end the answer should be positive here. So basically entropy should increase and the process should be spontaneous. So I hope this question is clear to you guys.